At first glance, this consistent ways. They do this by literally prying these photons apart. This is spectroscopy. Explained. Spectroscopy is the study of how matter can detect through the visible spectrum, but also a bit into the infrared and the ultraviolet. Webb is just infrared and can look at the light that is emitted from billions of years ago. And of course, the images from Webb are really spectacular, but this is what flutters the hearts of scientists. This spectrum shows the light that penetrated the atmosphere of a planet called WASP 96b. The light being measured comes from the planet's host star, some of which skims through the atmosphere. Humans are a long way from directly imaging exoplanets, so telescopes like Webb will use spectroscopy to find those chemicals that could support life in their atmospheres. Which is why Webb's first spectra is so amazing.
You're actually seeing bumps and wiggles that indicate the presence of water vapor in the atmosphere of this exoplanet.
Incredible. But it's one thing to identify single elements or simple molecules, but deciphering whole foreign bodies like Dr. Owajawek.
How do you know? Oh my God, it took us a very long time to figure this out. It really took us many, many decades, and it took us many, many fantastic new instruments.
If all of our astrophysical objects, or anything that we're looking at, were made up of one element, this would just be so easy. But we don't. So we have to do experiments on Earth like this to prove what we're looking at looks like what we are thinking we're looking at. So in here,
and measure basically what these kind of, as you said, fingerprints of those different transitions for different elements are.
Okay, so we're always comparing to sort of the fingerprint of what we have, and then if it has deviated from that, that is the new information from what we're looking at.
Correct.
Is pry open its contents.